Okay, so I'm going to show you something new here. Before I do, so up here, we stored the number 13 and we moved it to pin 2 and to some other ones, but we stored the number 2 here in the word LED. And so whenever we use the word LED, really what it represents is the number 2. And so here it says go to pin 2 and set as an output. And then here it says digital write, and so whenever here's the pin number, so it says take pin 2, turn it on, take pin 2, turn it off. Okay? So anytime we have a number, we can store it in a variable. And this can be a useful tool for a lot of reasons. But let's do another one. So we're going to make another integer. And this time we're going to make it be our wait time. And we'll set it to be 1,000 where it's starting right now. And so we can replace the delay here with the word wait, because the word wait represents 1,000. Okay? And so here's why this might be useful. There's two reasons. Well, there's a bunch of reasons, but the main two are this. Let's say that I want to change these delays, and let's say I have it used a bunch of times and I want to change it across the board. If I change it once here, and I've got it used maybe like 10 times here, I don't have to go through and find all those 10 times. Same thing with the pin number for the LED. I use that pin number 3 times in this sketch. Okay, you could have a sketch where you use it 100 times. I don't want to go through and have to change it if I rewire the LED to a different pin, so I put it up here so that I can make changes to it and it doesn't affect the sketch. So if I move this to pin 4 and I've used this word LED 100 times, I only have to change it the 1 time here. Okay, and then the second big reason is because when we have a variable like this, we can manipulate it. Okay, I can make this sketch so that it says, wait. So I initialize the variable here. Now I can do some math with it. And say wait is equal to, so I'm changing the value of it, the number wait plus 100 semicolon. So what's going to happen is every time we go through this loop, the word wait, or the number stored in wait, is going to increase by 100. And so basically the amount of delay in this sketch will increase by 1/10 of a second every time for the loop. So the lights are going to stay on longer and longer. And if you want, you could change this to a starting value that's small. So maybe we start with 100 and we go up. Okay, and this is the kind of the basics of it. Okay, you can square it so it increases like I guess this would be exponential. I think it would be, no, it'd just be to the power of 2. But you do something like that, you can multiply it by something, so you could double it every time through, or you could add something to it. Or for that matter, you could subtract something from it. Okay? And so those are all ways you could do it. If you're adding or subtracting, another way we can write that, let's say if we're subtracting 100. So wait minus equals 100. We'll do the same thing. Okay, we'll take the value, subtract from it 100, and reset it into wait. Okay, or if you wanted to add, you could say wait plus equals 100. Okay, that would do the same thing. Alright, so now I want you to kind of mess around with this and see if you can make the delay change each time you go through the loop.